Next up is just a short intro on vapor pressure. So this is something that we'll touch on more later on and more so in 102. And so let's start off by imagining, let's say that you have a glass of some water. So this right here is water. If you let this glass sit there for, a couple of weeks, maybe, I don't know, a couple of days, what's going to happen to all the water? Well, it's going to evaporate all away, right? So the liquid is going to turn into a gas and it's going to evaporate away until there's nothing left. But what would happen if you then closed this container, right? Close this container. Would the water ever fully disappear? And the answer is no, right? So the water would turn into a gas, but it would never fully disappear, right? You'd still have some water left. Once this air up here got saturated, no more liquid would turn into gas, and it'll reach what's called a dynamic equilibrium. We'll touch on this later on, but basically it's not that nothing is happening, but it's that the liquid is turning into gas at the same speed that the gas is turning into a liquid. And so it looks like nothing is happening, but technically the liquid is still turning into a gas and the gas is still turning into a liquid. And so since we have a gas here, the gas is going to exert pressure. Right, and this pressure is called vapor pressure. So vapor pressure is the pressure of a gas above its liquid. And if you think about what would happen if you took this gas and you increased the temperature, well, eventually, you'd push that equilibrium towards more and more gas and faster gas, right? So you'd actually increase the moles of water as well as increasing, the speed of these collisions. And so you have a kind of a double effect of increasing pressure. Make that green, purple, increasing pressure. So that's what you can see in this little picture here. So know what vapor pressure is, and know that when you increase temperature, vapor pressure increases. Like I said, you'll touch on this more so later on, but there's kind of one type of problem that's kind of common here and one useful example. So we learned about gas evolving reactions before, and so you have this kind of reaction here, and then you're turning it into a gas. And say you wanted to record how much gas am I making? Maybe this gas is valuable and you can use it. So how would you figure it out? Well, one way would be to see, to basically force the gas through some water into a collection flask and to see what the pressure is, right? So if you say you have a pressure here of 750 torr, right? How much of that is from your gas versus the water? So you can find the partial pressure of water through textbooks, right? It's a standardized piece of data. So the partial pressure of water is going to be 25.2 torr, right? And then what you want to know is what's the pressure of the gas? What's the pressure of the gas? And so, right, it's the same equation as before. It's that your total pressure is going to be the sum of your pressures, right? So we'll have the pressure of the water and the pressure of the gas. So we know the water, we know the total. All we have to do then is solve for the pressure of the gas. And so you end up getting, let's see, 725 torr. So not too important of a concept, but just in case you see this kind of problem or this question, you can solve it